Some, when initially introduced to relationship models, find them a bit overwhelming, and they really shouldn't because they're actually composed of just a couple very simple relationships, and I'll go over those in this particular segment. The simplest relationship is one where you have two different variables and A influences B in a way that B changes in the same direction that A does, or A adds to B. And think about the temperature outside in a thermometer. If the temperature goes up, the thermometer goes up, and if the temperature goes down, the thermometer goes down. In a similar way, if you turn a faucet and run water into a glass, you're filling the glass. The the faucet adds to the water in the glass, but if you slow down the flow of water, it still adds to the water in the glass, just not so fast. So it's adding to it, but not quite so fast. So it's appropriate to think about the nature of the variables that are part of this relationship in order to understand whether it's strictly a changes in the same direction or adds to relationship. Now the opposite of that is where variable B changes in the opposite direction of variable A, or variable A subtracts from B. And it, as I said, it's just the opposite of the previous relationship. There are a couple of different notations that are often used in relationship models. Personally, I find the notation, all of the notations, annoying because they sort of just create noise on the diagram after a while, and my preference is to just leave out the notations and simply go with colors, so that B means same or adds to, and red means opposite or subtracts from. Use whatever convention is convenient as long as you tell people what your convention is. With those two simple relationships, you can build a couple of more intricate structures, one being a situation where A influences B, and the result of which B influences A to influence B even more. It creates an exponential growth scenario. It's the way a savings account operates. It's the way populations grow. The larger something is, the faster it grows. And you can also have the alternative to this, which is an exponential decline. Consider that the more a civilization declines, the faster it declines. It's just running the growth structure in reverse. It's the same structure, just composed of two opposites as opposed to two same. When you create a relationship model, it's appropriate to label the structures so that someone else gets a hint of them right away. I mean, very quickly, so that if you label the structure itself in terms of what it is that's growing or what it is that's declining, someone can simply look at the label and know what this loop is doing, as opposed to having to actually study the relationships in detail. And note that these two structures only contain two relationships. You might actually have a dozen relationships in a reinforcing loop or in a decline loop. The last structure is one where, given a goal and a current situation, the difference between them creates a gap. That gap influences action intended to move the current situation in the direction of the goal. And when the action actually moves the current situation all the way so that it reaches the goal, the gap is zero and there's no more action. It's called a goal-seeking or a balancing structure. It's the way almost everything gets done. Anytime you decide to do something, you're actually creating a goal-seeking structure to change the current state into what your intent is through some action. So all goal-seeking structures you should endeavor to label them, like I indicated, you should label uh, growth structures or decline structures, so that if one looks at the label, it's apparent simply by looking at the label what the structure is intending to achieve. Now, as I said before, actual structures can contain numerous influences in the structure itself, so that it might not be completely evident immediately whether it's a growth or a goal-seeking structure. The way that you can tell one from another is to simply walk the structure and count the number of opposite influences in the structure, and if it is 0 or even, then it's a growth structure. If it's odd, it's a goal-seeking structure. And it, by simply look, by definition, I mean, this contains no opposite structures, so it's growth. This contains an even number, so it's the opposite of growth or decline. This contains one opposite relationship, so it's a goal-seeking structure. And then you may find that initially it's a little overwhelming, but if you just, after you spend a few minutes with them, it gets pretty obvious. So no matter how complex the relationship model may initially appear, it's just some number of these basic relationships interacting with each other. Think of it as Legos, building blocks that you, with a few simple Legos, you can build an amazing number of things. Well, with these few relationships, you can build any relationship model you need to construct. So, hope you found this of interest, and I'll see you in another video soon. Bye.